All right, there was an observation that was made here. Now, however, our answer still remains correct, but there is just a deeper explanation I need to give as regard this. Now, if you look carefully up, and if you look at the previous lecture, I did something, and that is what I want to explain to us here, so that we will not, so that we will clear our doubts, especially when it comes to this area. Now, I said the meaning of this statement, I made a statement here. I said the meaning of this statement means 0.0244 gram of benzoic acid reacts with 1 ml of sodium hydroxide before. Are you getting it now? That means by standard, wherever you have 0.2 molar 1 ml of sodium hydroxide, it is 0.0244 gram of benzoic acid that reacts. So therefore, we can say 0.0244 gram benzoic acid, which is C7H6O2, react with how many ml of sodium hydroxide? 1 ml. Then, of course, we have 1 ml sodium hydroxide. So what I'm going to do, I'm going to just push this one to this side a little, so that we can have space to write 1 ml sodium hydroxide. Now, if you have this, if you look at each of the individual this thing we do here, the reason is because of this ml and ml I put here for clarification purpose. So 0.0244 gram give 1 ml sodium hydroxide. Therefore, 10.15 ml, which is our titer value, this titer value, which is we can put it here because this 10.15 ml of sodium hydroxide will give X. Now, as a matter of fact, here you can cross multiply, and this is going to give us this multiplied by this and this times this. Now, if you look at this equation very well, when you cross multiply, ml will always cancel ml. Are you getting it now? So at the end of the day, we have X will be equals to 0.0244 times 10.15 gram of sodium hydroxide. All right, X would be equal to, when you multiply that, it's going to give us this value, gram of sodium hydroxide. So what I'm trying to say here is there is no need of you putting this. However, the reason why I put it like this is so that you know that we are actually reacting with a particular mole of this sodium hydroxide. But in the molecular term, if you want to actually express it, there's no need of putting this. All right, because the mole has cancelled. This mole that was here has cancelled with this 1 ml that is undisclosed, that it did not say. So there's no need. So your answer of milli equivalent will always be in gram. Now, however, there's also another observation I made here, in which this concentration here, I put in these values. Why the final answer will give us this, but the explanation, some persons are having it, they are finding it difficult to understand. Everything here will still give us the same answer, but the explanation, some persons are finding it difficult to understand. Now, one thing that you should understand is that KPC is concentration of the aqueous phase of the acid in the organic phase all over the concentration of the acid in the aqueous phase. Now, however, this amount you have here is also concentration. But if you want to actually express it, you can say the concentration in the aqueous phase, in the organic phase, should be equal to the mass, which is 24666 gram, divided by the volume of the acid, because concentration is either in gram per mole, mole per dm cube, gram per dm cube, etc. Are you getting it? So if you want to express concentration in gram per mole, it will now be 0.24766 gram. Now, but by standard, if you already understand this, you know that it was 10 ml of the acid, which is benzoic acid, because they say you should prepare 10 ml of each of the aqueous and organic phase. So if you already understand the practical, you are supposed to understand that it was a 10 ml that was actually reacted with sodium hydroxide. So this mass you have here is for 10 ml. So if you want to get the mass for 1 mole, which is the concentration, you can now say this divided by what? 10. Are you getting it now? Which is going to give us 0.24766 gram per mole. Are you getting it now? Now, okay, this is supposed to be 0.0024766 gram per mole. Now, the reason why I did not put it in that gram per mole, because you already know that this amount is in 10 mole. So if you want to put it in gram per mole, just divide by this. But at the end of the day, it's going to give you the same answer. But it's also good that we express it like this. So the concentration of A organic in gram per mole will be this. Now, however, the concentration of A in the aqueous phase in gram per mole will also be this amount you have here in gram, which is 0.02684 gram divided by how many mole of the aqueous phase did you actually withdraw. You withdraw 10 mole. That was what was used for the practical. So this was the entire concentration in 10 moles, right? Now, in 1 mole, you have to divide by 10. If this is the entire one in 10 mole, so to get in 1 mole, you have to divide here by what? 10 mole. Of course, this is mole. And this will give us 0.002684 gram per mole. Is that okay? So that is the only discrepancy that we have here. So if you want to put that now, our KPC is concentration of organic in gram per mole all over concentration of the aqueous phase in gram per mole. The answer will still give you the same thing, which is 0.024766 gram per mole divided by 0.002684 gram per mole. If you cancel what you have here, and this is going to give us the correct answer, which is 0.024766 divided by 0.002684. Think so, 2684, which will give us 9.227. There's no unit for KPC. So this is just the only thing I want us to express out, so that we will not make these mistakes in the exam in case. But if you do it the same way, you still get your KPC and your different concentration. So when they ask you for the amount in the organic phase, this will be your amount, 0.24766 gram in organic phase. Amount in aqueous phase, this will be the amount in aqueous phase. In how many mole? That was why I put dot mole, which is the mole of what was used for the titration in 10 mole. This is the amount in how many mole? In 10 mole. So if you want to calculate the concentration now in gram per mole, saying you want to convert, if this amount is in 10 mole, so 1 mole will be equals to what? You just divide by 10, which will not be the amount in gram per what? Mole. Are you getting it now? The amount in gram per mole. But at the end of the day, everything will still give you the same thing. And for this practical, because you are using the same amount for both the solvent and this, you don't need to actually do all this. But it's just good that we express it so that people that are having doubt, we understand better. Now, also, these concentrations we have here in gram per mole, we can also convert them to mole per dm cube, so that it tallies with what we have here. But if you are not interested in that, just kukuma end the video here. What I mean is, you see these values we got here. What are the values? The first one for the organic, 0.02476 gram per mole, right? Y for the aqueous phase is 0.02684 gram per mole. Now what I mean is, if you look at here, I solve my concentration in mole per dm cube, right? If you look at it here, I saw my concentration in mole per dm cube. Now I want to convert this concentration in gram per mole to mole per dm cube. How do I do that? Like I told you, if you know your brain may not be able to carry this, or if it will breed confusion, please just log out now. Thank you. So if you want to convert this concentration, let's say you have the concentration in the organic phase to be 0.02476 gram per mole. You want to convert it to gram per dm cube. Firstly, you have to convert this mole. You want to convert it to mole per dm cube. Firstly, you have to convert this mole to dm cube, right? Now, 1 dm cube is equals to how many mole? Is equals to 1000 mil. So you can come here, since you want to cancel mil from here and make dm cube under, you can say 1000 mil, this is our conversion factor, is equal to what? 1000 mil is equals to what? 1 dm cube. This is the representation here. 1000 mil is equals to 1 dm cube. We put it like this. 1000 mil is equals to 1 dm cube. In such a way that mil can cancel mil. 1000 times this is going to give us 0.02. 1000 times everything you have there will be 1, 2. I think it's more than this. Let me check. 1000 divided by what you have there, 0.02476 times 1000. This gives us 24.76 gram per dm cube. It means per 1 dm cube you have 24.76 gram. Now, to convert it to mole per dm cube, what do? You multiply by the molar, or you divide by the molar mass. Are you getting it now? You divide by the molar mass, because 24.76 gram per dm cube, 1 mole of this substance, you now come here to convert it to mole per dm cube. 1 mole of benzoic acid contains how many gram? Contains 122 gram, according to what we say. You see how I'm converting these things. These are little conversion factor, but if your brain may not carry, you can just quit here. Like I said earlier, gram cancel gram, so everything that now change to mole per dm cube, because 1 mole of any substance is equals to the what? The molecular mass. The molecular mass of benzoic acid is 122. So that at the end of the day, you now have 24.76 divided by 122 and divided by 122, and that will give us 0.2029, which is approximately 0.2. Now, if you come back here and see what we got here, let's look at what we have here. You see, in that organic phase, what we got here as our concentration is 0.203. Now, if you look at what we got here, in mole per dm cube is 0.2029, which is approximately 0.203. Are you getting the mole per dm cube? So using C1V1, you still arrive at the same thing at the end of the day. But the most important thing is understand how these conversions take place. Is that okay? So that is our concentration of the aqueous phase in mole per dm cube. So we actually came from this gram per mil. Where is it? The gram per mil we got to what? Mole per dm cube, and it will still give us the same answer in concentration. Now, how about this of 0.22 mole per dm cube? Now, we can come here and say 0.22 mole per dm cube. Let's try and answer it. First of all, we have to convert this to what? Gram per dm cube. So this gives us 0.022 mole per dm cube. To convert, mole per dm cube, yeah. To convert to gram per dm cube, okay, this is not what we are going to use. This is what we have. We want to convert that values we got first, the first value we had, which is gram per mil, to this mole per dm cube. So what was that value in gram per mil? It was 0.00268. Let me write it down. 0.002684. All right. So let's come up. Yeah. What we have here was 0.022. Right? So what we had here was 0.002684. Then we have it as what? Gram per mil. To convert it to mole per dm cube, gram per dm cube, what do? First of all, you have to convert this mil to dm cube by noting that 1000 mil is present in 1 dm cube. The reason why I have to do it like this, so that mil will cancel mil, And then if milk cancels meal, you have gram per dm cube by multiplying by 1000. This is going to give us this multiplied by 1000. This will give us 2.684, right, gram per dm cube. Now to convert this gram per dm cube to mole per dm cube, you multiply by the molar mass by saying that 1 mole of this, right, contains 122 gram. That is the reason why molar mass is usually expressed as gram per mole. Gram per mole. It means 122 gram is present in 1 mole. But because we want to cancel gram, you can express it as 1 mole, right, is equals to 122 gram. So that gram can cancel gram. When this divide this, so you have 2.684 divided by 122, that will give us exactly 0.022 mole per dm cube. So the concentrations in gram per mole are equivalent to that in mole per dm cube, which makes our this thing very, very correct. But for the practicals, the way they did it in the manual, that is the way I just followed it. But then someone actually called my attention to it, that they were having some difficulties understanding this, and actually gave this suggestion. That was why I have to make it so that everybody will be aware of what we are doing, all right, and the clearest possible explanation that you can get from here. So thank you very much for your time. We'll see you in the next one.